1 million eggs just rolled across the seafloor like marbles. And the scientists who saw it still can't sleep at night. That's not the opening line of a sci-fi trailer. It's the stunned reaction of a Canadian marine crew after a long dormant volcano, hidden a mile beneath the waves off Vancouver Island, suddenly coughed up a mineral-rich plume and revealed the planet's largest known deep-sea nursery. But here's where it gets controversial. Some researchers now argue that protecting this volcanic playground could be more urgent than saving polar bears, because once it's gone, an entire evolutionary shortcut for deep-sea life disappears forever. In a nutshell, an underwater volcano, once written off as extinct, is very much alive, pumping out hot, mineral-laden water that turns its summit into a giant natural incubator. The warmth attracts white skate rays that lay leathery egg cases almost half a meter long, each one a nutrient-packed survival capsule. Preliminary counts suggest more than 1 million of these cases now carpet the crater, making it the biggest skate nursery ever recorded. The find throws a spotlight on how little we know about the deep ocean and how quickly human activity could erase these hotspots before we even map them. A volcano that refused to stay extinct? Back in 2019, Fisheries and Oceans Canada sent a remotely operated vehicle to inspect a seamount rising 3,600 feet from the abyssal plain. The plan was routine: snap a few photos, grab a couple of rock samples, move on. Instead, the ROV's headlights lit up billowing clouds of shimmering particles and ghostly white shapes gliding through the haze. Hundreds of white skate rays spiraling around the crater rim, like traffic over a busy airport. The volcano, officially labeled inactive since the last survey, was quietly venting 200 degrees Fahrenheit water loaded with calcium, iron, and silica. In other words, the mountain had turned itself into a geothermal crib. And this is the part most people miss. The rays aren't just visiting. They're banking on the volcano's heat to slash incubation time from a glacial 4 years down to, scientists estimate, just 18 months. In the deep sea, where every extra day in the egg raises the odds of predation or crushing pressure, that's the difference between a species that limps along and one that thrives. An unprecedented egg deposit, or a ticking clock. Imagine walking into a football stadium and discovering the entire field paved with ostrich eggs. That's the scale biologists are grappling with. High-resolution photomosaics, stitched together from 12,000 individual frames, show egg densities topping 30 cases per square meter in some patches. Conservatively, that's 1.2 million embryos, roughly the population of Dallas, sitting on a volcanic slope no larger than downtown Vancouver. Each case, nicknamed a mermaid's purse, looks like a blackened samurai sword sheath. Inside, the embryo feeds off a yolk sac the size of a candy bar, enough to sustain it until it hatches at roughly 30 centimeters long. Already a miniature predator. The gamble is enormous. One female invests so much energy in a single offspring that losing even half her eggs to mining robots or shifting currents could collapse the regional skate population within a decade. Volcanic warmth, nature's fast-track incubator. Charisse Dupreez, the lead deep-sea biologist on the expedition, likes to call the site a slow cooker set to life. The volcano's summit is 300 meters shallower than the surrounding abyss, shaving off enough pressure and adding enough warmth to create a Goldilocks zone for embryonic rays. Picture a subsea jacuzzi where the jets are plumes of 90 degrees Celsius water diluted to a balmy 4 degrees Celsius. Still frigid for us but tropical for creatures evolved at 1.8 degrees Celsius. But here's where opinions split. Some chemists argue the mineral load could harden the egg cases too early, trapping hatchlings inside. Others counter that trace metals actually reinforce the collagen walls, making them shark-proof. The debate is far from settled, and every new dive seems to add fuel to both camps. A living laboratory and a political hot potato. Beyond the rays, the volcano hosts gardens of bubblegum pink corals, glass sponges older than the Roman Empire, and bacteria that eat sulfur instead of sunlight. In theory, that makes the site a living laboratory for studying how life might evolve on Europa or Enceladus. In practice, it sits smack in the middle of a seabed lease area where companies are eyeing cobalt crusts for next-gen batteries. So here's the uncomfortable question. Do we declare the volcano a marine protected area and risk slowing the green energy transition? Or do we mine carefully and gamble with an ecosystem we barely understand? Most documentaries will tell you conservation is the obvious choice. Reality, as always, is messier. Conservation curiosity. Your turn to weigh in. The million-egg volcano is more than a headline. It's a mirror reflecting our priorities. If we can rally global support to protect a nursery we never knew existed, what else might we save by looking deeper? And if we choose extraction, are we prepared to explain to future generations why an entire lineage of deep-sea flyers vanished for a few extra battery cells? Now, over to you. Should untouched volcanic nurseries get the same legal shields as rainforests? Or is controlled mining a fair trade-off for renewable tech? Drop your take below. Agree, roast, or rewrite the rules. The comment section is officially open for deep-sea debate.